This video is on solving linear systems by graphing. A system of linear equations is two or more equations of lines considered together. To solve a system of linear equations means to find the ordered pair, the x and the y, that satisfies both equations. One way to do this is by graphing. We want to graph each line on the same set of axes and find the point where they intersect. This ordered pair is the solution of the system of equations. Let's take a look at an example. So here we have the system, x minus y equals 2, and 3y plus 2x equals 9, and we need to solve that by graphing. First of all, I want to rewrite each equation in slope-intercept form. So subtracting x on each side is going to give me negative y equals negative x plus 2, and then dividing each side by 1 gives me y equals x minus 2. So there's one equation that I'm going to graph. And now I have to rewrite this one. I have 3y plus 2x equals 9, so I'll subtract 2x on both sides and divide everything by 3. So that gives me y equals negative 2/3 x plus 3. And I'll graph that line as well. Okay, so to graph, I'll start with y equals x minus 2. I begin with my y-intercept, and I have a slope of 1, which means up 1 and right 1. And for this, I'm going to do, because I'm looking for the exact point where they intersect each other, I'm just going to do a whole bunch of dots here, because I don't know where along here they're going to intersect each other. And instead of going just up 1 and right 1, I can also go down 1 and left 1. So there's my first line. Let's do the second one here. Y equals negative 2/3 x plus 3. I'll begin with my y-intercept of 3, and I'll go down 2 and right 3. Oh, and look, I hit it right there. Let's just do another 1 or 2 for good measure. Down 2 and right 3. And now I can draw these two lines because I've found the point where they intersect each other. Oops, sorry about that. And this line here. And the point where they intersect is this right here, and that's the ordered pair 3, 1, and that is my solution. If I wanted to check to see that that was correct, I would plug 3 in for x and 1 in for y into both of these equations. And actually, let's do that real quickly here. So 3 minus 1 is indeed 2, and 3 times y is 1 is 3, plus 2 times 3 is 6. 3 plus 6 is equal to 9, so that does indeed work. Sometimes a system of equations can have no solution or infinitely many solutions. If the graphs of the two lines are parallel, they will never intersect each other and the system has no solution. There is no ordered pair that is going to work in both of those equations. If the two equations are the same equation, but just written in different ways, then the system has infinitely many solutions because it's almost as though you were graphing one line right on top of the other. So let's take a look at a couple of systems of equations here and determine the number of solutions. First, we have 3x plus y equals 6 and y equals 3x minus 5. So this is nice. This one's already in slope-intercept form. Let's go ahead and turn this one into slope-intercept form by adding 3x to both sides. So that turns into y equals 3x plus 6. And now comparing these two equations, I notice that they have the same slope, which means they are going to be parallel lines, but they have different y-intercepts. So each line is going to have a slope of 3, but they're going to cross the y-axis in different places, so they are not the same line. So since these are parallel, this system has no solution. And let's take a look at number 2 here. So I have y equals negative 2x, or y minus 2x equals 4. And negative 6x plus 3y equals 12. I'll rewrite each of those in slope-intercept form. This one I'll add 2x to both sides. And this one here, I'll have to do 3y and add 6x to both sides plus 12. And then dividing everything by 3. I get that y equals 2x plus 4. And you will notice that these two equations are exactly the same. Y equals 2x plus 4 and y equals 2x plus 4. They are indeed the same line, so they have infinitely many solutions. So here are a couple practice problems I'd like you to try. I want you to go ahead and stop the video and copy these into your math journal and give them a try on your own. Okay, let's take a look at these equations here. So it says solve each system by graphing, and the first one is 2x plus 3y equals 12, and the next one is 2x minus y equals 4. So I want to turn each one of those into slope-intercept form. So I'll subtract 2x on both sides, and then divide by 3. So this gives me y equals negative 2/3 x plus 4. And I'll go ahead and do this one over here. Subtracting 2x on each side leaves me with negative y equals negative 2x plus 4. And dividing everything by a negative 1, I have y equals 2x minus 4. So they are not the same line and they don't have the same slope. So I'm going to have one solution to this system. So let's go ahead and graph this one first. So I'll start with a positive 4, and my slope is negative 2/3, which is down 2 and right 3. And I'll just go ahead and do a whole bunch of points here, or up 2 and left 3. Okay, and my second line is y equals 2x minus 4. Starts at a negative 4 and has a slope of 2, which is up 2 and right 1. And this is looking good. Oh, there we go. There's the point right there. So I'll do another 1 or 2 for good measure. And I can go ahead and draw my lines. And I see that they intersect at this point right here, which is the ordered pair 3, 2. So that is my one solution to this system, which I discovered by graphing. Let's take a look at our second equation, our second set of equations here. So this one I'll rewrite in slope-intercept form by subtracting an x on both sides and then dividing by negative 2. That's going to give me y equals 1/2 x minus 2. And my other equation is already written in slope-intercept form, y equals 1/2 x plus 1. And I notice right away that I have the same slope, so that means these lines are going to be parallel, and different y-intercepts, so they are not the same line. So let's just go ahead and graph them. I'll start with this one. My y-intercept is 1, and I'll go up 1 and right 2. And I'll do just a few points here, or down 1 and left 2, and do just a few points there. I'm going to go ahead and draw this because I already know that they're not going to intersect each other. And then y equals 1/2 x minus 2, starting at negative 2 and graphing a couple points with the slope of 1/2. I have this line right here, and you can see that they are indeed parallel. They will never intersect, so this system has no solution. So in this video, we took a look at how to solve a system of linear equations by graphing, by identifying the point where the two lines intersect each other, which is the one solution to the system. Sometimes if the lines are parallel, you can have no solution, or if the two equations actually end up being the same line, you can have infinitely many solutions.